topic is human aspect in automation. Before we start earnestly and dive into the details of the topic, let us first touch upon a few of the things that really touch our daily lives in automation. Automation, as we know, is a method by which we imply to simplify and do things in an easier, more efficient, safer way. Automation can be used in various ways, in a methodology, in production, in our daily lives, and also in critical applications like medical sciences. Automation right now is a integral part of our lives. Whatever we may wish, whatever we may decide, it is here to stay, and technology is moving to make our lives more simpler and faster. And automation is playing the most important part in this. Now, automation can be, again, further divided into different categories. We have robotics, we have machining interfaces, we have artificial intelligence. So today in this, we will touch upon various aspects of automation and how human aspect plays an important part, both in terms of use, both in terms of being a part of that technology, and also what repercussions the automation can have on our field of work. So let's start first with what exactly is automation. Automation is the progressively transferring, regulating, and controlling function from humans to a technical system. This results into higher efficiencies, safer methods, and faster way of working. There are some debatable questions on this. Some of you might question, how is it safer? If an automated system develops a fault, there is no other angle to correct it. Definitely. So we'll touch upon all this while we talk about automation and human aspect further. One of the prime examples of automation is in the industry. Industry is the prime mover of everything which moves and develops in the world otherwise. The automatic control of the manufacture of a product through a number of successive stages is automation. The application of this automatic control to any branch or industry of science also is automation. So we'll first go into a brief history of robotics, of automation, which you will see on the slide, and you will refer to it, that it started in a period as ancient as Greece and Egypt. This was by way of the water, which was powered for ceremonies, in the sense that there were certain ancient ceremonies in which water was used as a power source, and this was the first basic concept of automation in human life. 14th and 19th century, clockworks and other things driven for entertainment were a part of robotics and automation, or you can say the precursor. Motor-driven robots for first 1928 were brought into operation. The first industrial robot came in 1961. The electric-driven motor arm came in 1969. Now, automation has moved at a much faster pace in the 21st century. We have used automation mainly to overcome human capacity problems, automation of physical tasks like loading, unloading, packing, routine tasks like production increase, welding, nailing, riveting, even segregation. So we are moving at a fast pace in mechanization in the industrial sector in the 21st century. Complex and safety critical tasks, control tasks, management tasks are also now moving for automation and towards automation. The prime example of automation in our lives is also your cell phone. There are so many things automated through your cell phone, which today are a part of our lives. Without knowing and unknowingly, we are using automation even to the extent of school children using the technology for their benefit. In our lives today, automation uses optimizing for logistics, detecting fraud, that's in the financial sector, composing art, we have digital art, conducting research. A lot of research and testing methods are now automated. The data analysis is much faster through automation. Translations, intelligent machine systems like robots, and they are transforming our lives for the better. You will be surprised, and maybe some of you might not be surprised, but everything what Amazon, Facebook, IBM, and Microsoft is using is a part of automation and intelligence, automated intelligence in our daily lives. Tesla is one of the prime movers in the self-driven cars, and that is what they're using for automated controls of automobiles. The slide shows automation in our lives. You will be very, very aware of all this which is being used today in our lives. Robots, medical sciences robots, automobile industry, in the normal industry, even mobiles. The industrial robots sector is one of the most actively used and efficiently used automation systems in the world. Most of the automobile companies and automobile factories are right now automated to 90% of the extent. Certain tasks which are only left to manual labor are the ones which are being done by manual labor. Otherwise, automated robots and automated lines are a part of our lives today. The automobiles are being made more efficiently, faster, and much more effectively. The welding which takes place in an automobile is much safer, much more uniform, and the quality is of exceptional standards, which a human being can never give. You'll be surprised to know that the rate of production of a car in Maruti today is 1.1 minute for one car. That is the time frame in which a car is being produced in Suzuki. In the Italian manufacturer, automobile manufacturer, Fiat, the production rate is 55 seconds. Okay, sometimes the capacity is required at the rate which marketing is able to sell the product also hampers the effectiveness and the speed of the automation. But the capability of the system is such that the factories in Germany and in Italy are and will be able to produce one car every 35 seconds if allowed to, and if the market demands. That is the rate at which we are talking of automation working in the industrial sector. Now, the industrial sector uses these robots for repetitive tasks. You can see it on the slide. For high-speed work, sensing operations, high precision movements, as I was explaining, welding, cutting to the right extent, pre-planned trajectories, and with no intervention of humans. If we look, or if you are able to look on YouTube on a video showing the manufacturing of the Mercedes C-Class car, or even the Volvo, you'll be able to see the extent of automation of these industrial robots which has taken place in the industrial sector, especially in automobiles. The slide also shows you where automation supports us in our daily lives or in which sectors. The first slide on the left corner is the one which shows you a space control station. Automation is a huge part of a space control system, a space control project. From data of each and everything from the space module, from the spacecraft, it is able to translate it, and the people on the ground through this automation system are even able to control activities in the space station or in the space module. Activities which an astronaut would be subjected to some dangers or does not possess the right capability, the environment, everything can be controlled from the space station here through automation. The second slide on the right shows you a very simplified automation system today, what we have in our homes, or most of the homes. Automation in homes is a part of our lives now. You can control lighting, you can control blinds, curtains, air conditioning, heating, even to the extent of whether the door has to be locked or unlocked is through automation. Automation has come to stay in our daily lives, and a normal family and a housewife is also using automation to that extent. The human aspect, the role that it plays, we'll discuss about it later. But let's start first viewing what all we can do. The third slide gives you one of the most important aspects of automation, which is in security. In the security environment today for a country, for an organization, it's an important aspect where automation plays the most important role for detecting, for projecting the data, and then for responding. The American retaliation with drones is a part of security, which is an automated form of high technical inputs given from the ground and then converted to the drones, which can search and destroy a target. The same goes at airports, where we see that the airport system not only detects but also alarms and responds to a threat which is seen by the automation system. So these are some of the examples that we see where automation is supporting humans in the areas. Now, one of the most important aspects when we are talking of automation is HMI. HMI means human machine interface. The human machine interface actually works how the human is able to collaborate with the machine, whether the machine is able to respond the way the human wants it to, or whether the way we want it to. The human machine interface is the first critical aspect of automation. It is the one which drives automation and defines the boundaries to which the automation can work. As the name implies, it's the graphic interface. It allows humans and machines to interact. Human machine interface is the primary step, as I told you, or the first step for automation. The human machine interface also provides the visual representation of the control system. This can be in various forms, in verbal, audible alarms, in graphic interfaces, in showing you how actually the product is behaving, how the machine is behaving, and also what corrective action is being forwarded by the machine. That also is displayed to the human operator or the controller of the machine. So the human machine interface is a very, very critical part of the whole system of automation. Now, before we go into details of automation, we also need to look into that there are certain risks connected to automation. Not all automations are fail-proof or safe. However, the world is moving very fast into correcting these systems and taking care of these anomalies so that the automation that we work with is safer and better. So some of the risks that we want to talk about is sometimes in the degree of procedures. So the automation system becomes too extensively overloaded to work on its own. Automation might fail due to various reasons. The technology is so complex or so low that the automation might not be possible in that. Cost effectiveness. Sometimes manual labor, like in the third world developing countries, labor is much more cheaper than automation. You might not want to automate the line to that extent because buying or spending money on robots is much more expensive, or on automation is much more expensive than actually putting people on the job. You can see an example today in Europe. On the tolls, the system is totally automated. Your car has a tag through and moves through the lines effortlessly. All cars are equal distant. Sensors are alarming and everything goes on like clockwork. But in India, we do not go for full automation in such places even. Why? Because we have cheap labor. On every toll, on every channel, you will find 4 people. On the barrier, 2 people, one person giving you a slip, collecting the money. And we are still working in that system because we find that labor is much more cheaper than automating the control. Now, the next point is legal requirements. Sometimes you cannot have a system, automated system, because of legal requirements. You might have to put everything under CCTV surveillance, but there are areas where due to legal requirements, you are not able to put CCTV cameras. So you cannot have control of visualization. Legal requirements also say that people have to be respected for their rights. So you cannot put automation in places where legal right, privacy, and other things of people are violated. Public opinion. Public opinion might be very strong against technology in certain places. They will resist technology to be put. And in certain cases, especially like India and the developing countries again, where vote banks are a huge issue, we are not able to put automated technology because getting the votes of the people is more important than making lives better and faster. So that's another thing which moves there. The example that I wanted to give you in pitfalls and also risks was, like, you take instance of a car which is self-driven, but there have been instances where the sensors have failed and the self-driven car has met with an accident. Although most of you or a lot of you will argue from the standpoint of that the technology is in nascent stages and still evolving, but then there are pitfalls and risks connected to automation in different fields in various ways, which will need correction definitely, and which will need to be kept in mind when we are designing a system of human interface with automation. The slide shows you now the advantages that we have in daily use in technology. It is the first representation again is showing you the same automated line in one of the automobile companies where the entire operation of the line from start to finish is being done by robots. The second one also shows you the automation controls today that we have in high-speed trains, from the track data to wind velocities to sensing the people and object on the track. Everything is done automated through an automated control system. Now, the advantages that this kind of systems give us is that the production levels increase. So productivity, as we have talked, increases. It increases precision and control. In trains, in aircrafts, the kind of precision and control that we have today is far better than what we had earlier. We'll be also going to a slide which will show us the progress that we have made in all these fields. Increased information and safety, purely because of the alarms and the feedback that the automated system gives. We have increased information and the safety has increased many folds. The aircrafts, as I said, is one of the main things which have benefited from the use of automation. This slide shows you very clearly, if you will see, how aircrafts have moved because of automation and because of systems becoming more complex and clear through automation, from the number of accidents that they used to have earlier to the new generation of aircraft. The slide is self-explanatory. If you look at 1961, we had million departures and hull losses in huge numbers. Even going with the same number of departures, the number of flight and aircrafts which are flying today, you can see that the accident rate or the kind of losses that we have suffered have become much more less negligible, and even to the extent that in certain cases, for the third generation, they are virtually zero. We do have accidents in aircrafts. The black box gives us information, but this is also a proven fact that the overall safety, overall precision, and losses have gone down. The safety has gone up, the precision has gone up, and the losses have gone down immensely, thereby saving human lives, making air travel much more safer, and getting people faster from one end to the other. The third generation aircraft, like the 737, 757, and 777, which are depicted here in the blue green, that is the turquoise color, show that their hull losses are nearly equivalent to zero, just slightly between 0 and 5, which were 10 times in 1963. So over a period of 55, 57 years, the technology and automation has moved to an extent to make air travel much more safer and much better. Well, having discussed the advantages and the use of automation and the way automation is helping us in our lives, we should also discuss the negative effects of automation on humans. In spite of making our lives easier and better, increasing productivity, improving systems in the industrial setup, there are certain effects which automation has on humans, which should also be kept in mind. They have increased the complexity for the human operator. The human operator had to operate very simple machines. Now the machines are much more complex, and his understanding and his training has to be much higher. The number of trainings that he has to go through to operate a machine, or just to know how to operate a machine, is much more. We have reduced safety margins. When a human operator was manually operating a machine, or a machine was being run on a manual system, the speeds were much lesser. Now, when the speeds are lesser, as you know, that if you're driving a car at 20 kilometers per hour, the resultant accident will not either produce such a grave situation, or it can be avoided altogether because the speeds are so slow. Whereas when you are moving at a very high speed, like in automation, the machines move at a very high speed, the margin of safety is reduced to a huge extent. If the automation fails, then the results are catastrophic. And that is where we need to keep alert, and we need to really monitor the system and take corrective action. The operators are left to deal with automation malfunctions. Now, earlier the operator had to just deal with his own malfunction, and he had to only deal with how he was performing. He could recorrect himself if he found that he had moved the tool a little faster. Now the operator has to move at the speed of the machine. A machine is moving at extremely high rate with the automated system, and the malfunction, if it takes place and the operator is not able to take corrective action, will have serious repercussions. One of the examples that I would like to share here with you is in one of the organizations where I worked, and we had an automated packing line for confectionery, bubble gums to be exact. Now the rate of packing of the machine was something to the extent of 2,000 pieces per minute. So you can really experience, if you visualize, the speed at which the machine was moving for giving 2,000 pieces per minute. And there were 20 machines of this capacity working together on the line. Now the automated line had to fill jars automatically, where the jar sensing automation system had to cut off the supply of bubble gums into that jar once 150 mark was reached. You can imagine, if the one machine was producing 2,000 pieces per minute, 150 pieces in a jar would just take 6 or 7 seconds. Now, if the system of bifurcating good pieces from bad, or the system of sensing whether the jar is filled or not filled, doesn't work or malfunctions, within a matter of 30 seconds, if the operator is not very, very careful, you will have more than 100,000 pieces on the shop floor lying, because there are more than 20 machines working simultaneously at that rate. So this is the rate at which we say that the operator has to also be aware, and the malfunction needs to be stopped in time, so that do not have serious effects of the malfunction. Now, there is also the final point of reduced possibility of practicing operational skills. The operational skills of the operator, he could fine-tune them with time, but now there is no time to fine-tune them, or the operational skills of the operator cannot be left not matching with that of the machine. So these are some of the effects on humans, which also puts tremendous load on human beings and operators. which need to be kept into account, which also result in certain HR issues in industry and in the organization, and which will have effect on how humans collaborate with machines. So if we go into an overview of automation, like it's being used in the oil and gas industry, space industry, railways, aircrafts, space, everywhere, as we have discussed earlier. Now, in the overview, we need to have the background and definition of one, what is the operator's role? Like we were discussing, that the operator roles becomes all the more important. His technique, his skill set, and his training is a very integral and important part of the whole system. The operator role for automation and for allotting the jobs that he has to do, one has to be the task allocation. That is a very important part in automation. You have to really see what tasks can be allocated to the automation system and what to the operator. The second one is the human system interface design. It is an important aspect that the human system interface design has to keep in mind the operator and the automation both. It cannot have to be designed only on one singular concept, either from the operator standpoint or from the interface automation point. The effects on the individual and the organization. As we briefly touched earlier, the effect of automation on the individual and the organization. If the individuals are not a part of the design system and of the automation system, they will feel alienated and they will not become a part of the change, not be able to embrace technology to the extent where the organization benefits, and shop floor problems will escalate. Human-centered automation is another one which is a part of the design of automation system which we have to see. The key issues of automation, if we keep on with this, the most important issue is human. And the human being remains the most flexible and powerful weapon. The human being is the most powerful weapon in the sense that we are able to justify, we are able to reason, we have the cognitive ability to think about a situation, which a machine does not have. In spite of whatever programming you might have in a machine, the human being mind is still more powerful than that. Artificial intelligence definitely is moving, but we are nowhere near how a human brain can respond to a situation and be more logical than a machine. One of the important aspects which I would like to just briefly touch upon again with you is that a professor of anthropology and history in Oxford, whose name is Professor Harari, has written a fantastic book by the name of Sapiens. In Sapiens, he gives us a very good example of how human mind has evolved over time and how we have achieved supremacy over other animals and other beings on this earth. The biggest advantage that human beings have is the ability to think, to imagine, to visualize, and to reason, which none of the other animals have. This is a fact. Even if we say that monkeys or apes are able to communicate with each other, they are not able to communicate with each other to the extent human beings are. Just an example is, it has been found by scientific studies that the monkeys can only warn each other that there is a tiger coming. Danger. That is the only thing that they can, and they look at a particular direction. Whereas human beings, if we want to tell each other even a way or a route to some place, we will be able to tell, you take that route, you'll find that landmark, you will see those lights, be careful there, there is a bridge there, it might be closed, you can take that alternative route. So these are all cognitive, visualizing, reasoning, and logic abilities which a human being has, which even animals do not have, or other or other beings on this planet don't have, leave alone machines. So that is why human beings become the most important aspect in automation. The automation system has to realize during designing of the interface and designing of the system that there will be an important role for the human operator or the human connected to the system to play along with that. One of the things that have to be kept in mind while designing of automation, or keeping in mind that whether it has to be distributed between the human being in what way, that the task is too difficult technologically to be automated. Now, there is still some lacking in the technologies that we have. We still have limitations. So we have to keep in mind whether this task can be automated or not. The production has a very small, short life cycle. Like in batch production, if you have large batches of production, automation plays a very, very normal role, that it is able to produce because there is a repetitive production. And if there are huge numbers to be produced, the automation system can work. However, if there is a design which only needs a prototype of 10 samples or 15 samples to be built all the time, and the life cycle is very, very short, then automation system will never work. It has to be done by a human or an operator. The automation has a limitation of commercial viability. Just for a very small issue, you cannot keep on changing your automation cycle and your automation system to suit a particular batch design or batch size. The task regard production of customized products. Now, there is a customized product where technology or automation cannot work. A very big example is precision watches, which are made handcrafted, especially in places like Switzerland. The ability to make a handcrafted, unique piece only rests with a human being and not with a machine. The automation system can definitely make it, but again, it becomes unviable. It doesn't fit into our commercial requirement, and we will have to look an alternative source where 10 people can work on that much more effectively, commercially viably, than an automation system to work. So these key automation systems where we have talked about human interference or human logic and human interfacing to take the necessary decision is an important part in deciding automation. I will now show you two videos which are a real life true incident where flight 1549 crashed near New York into the river. Now, these are a case study of how automation and human beings' logic and thinking, reasoning differ. Just have a look at these videos one by one. Then we can draw our inferences and talk about this. So the first video will show you how the investigation took place, and the two pilots who are shown here in this. This is a true incident in the history of civil aviation, where Captain Sullivan, who was the commander, took a decision to land the plane in the river, whereas the automated system was telling that he can land on the airfield. And that is what the inquiry took place. And just have a look, where the second video will explain how human logic, human reasoning was much better than in the automation system. So just have a look.
Too low, terrain. 50, 40, 30, 20.
Huh?
Successful landing at Teterboro, runway 19.
They can have a whole.
Multiple airports, runways, 2 successful landings. We are simply mimicking what the computer already told us.
You know, a lot of toes were stepped on in order to set this up for today. And frankly, I really don't know what you gentlemen plan to gain by it.
Can we get serious now?
Captain?
We've all heard about the computer simulations, and now we are watching actual sims, but I can't quite believe you still have not taken into account the human factor.
Human piloted simulations showed that you could make it back to the airport.
No, they don't. These pilots were not behaving like human beings, like people who are experiencing this for the first time.
Well, they may not be reacting like you did.
Immediately after the bird strike, they are turning back for the airport, just as in the computer sims, correct?
That is correct.
They obviously knew the turn and exactly what heading to fly. They did not run a check. They did not switch on the APU.
They had all the same parameters that you faced.
No one warned us. No one said you were going to lose both engines at a lower altitude than any jet in history. But be cool. Just make a left turn for LaGuardia like you're going back to pick up the milk. This was dual engine loss at 2,800 feet, followed by an immediate water landing with 155 souls on board. No one has ever trained for an incident like that. No one. And the Teterboro landing, with its unrealistic bank angle, we were not the Thunderbirds up there. I'd like to know how many times the pilot practiced that maneuver before he actually pulled it off. I'm not questioning the pilots. They're good pilots. But they've clearly been instructed to head for the airport immediately after the bird strike. You've allowed no time for analysis or decision making. In these simulations, you're taking all of the humanity out of the cockpit. How much time did the pilots spend planning for this event, for these simulations? You are looking for human error. Then make it human.
This wasn't a video game. It was life and death. So he's right, that's worth a few seconds.
Please ask how many practice runs they had.
Okay.
17. The pilot who landed at Teterboro had 17 practice attempts before the simulation we just witnessed.
The reaction decision time will be set at 35 seconds.
35 seconds, not enough time.
We only had 208 seconds total, so I'll take it.
Upload the link.
Now let's have a look at the next video, which will show you the simulation that was done and where the pilots were found that they had taken the right decision because the automated system earlier did not have the same parameters which the pilots had. Just have a look at that.
Upload the link. Return to LaGuardia. Now with an added 35-second delay in response time.
Birds.
Okay, I saw him. 35 seconds.
Time's up.
Here we go. Flight path vector. Going for 1-3. Activate confirm.
You are confirmed.
Okay, ready right for the airport.
Obstacle. Obstacle.
We're about 7 miles from Norway.
Caution. Obstacle. Terrain. Pull up. Pull up. Pull up. Pull up. Too low. Terrain. Too low. Terrain.
Extra speed.
Too low. Terrain. Too low. Terrain.
No, leave the flaps
Too low. Terrain. Too low. Terrain. Too low. Terrain. Too low. Terrain.
50, 40, 30, 20.
Let's try Teterboro.
Upload the link, please. Birds.
Autopilot off. Flight director off. Heck, time. 35 seconds.
Engine 1 and 2 fail. Turn.
Okay. Let's see if we can make it.
Okay. 298. seen the Teterboro out there?
I do. Way too low.
Obstacle, obstacle. Pull up. 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 Pull up.
Okay, so here in both the videos, it gives you a very clear example of how human logic and human reasoning was a better decision in this case as compared to an automated system. And the judgment which the automated system made, blaming the crash or the landing on the pilots, that it was not the right decision. A very important point which came out in these, if you must have noticed, was that humans have the ability to reason out and also to keep emotions in mind. 155 people on the flight was a point which was in the mind of these two pilots rather than just the automated system. The automated system will never feel how many people will die or what will happen if there is an error of judgment. It does not mean that the automated systems are wrong and should not be in place. What it also tells us is that the automated system needs to be used in collaboration with the human mind. And that is where what we are talking about is the human and machine interface and the way humans have to be used in the automated system. Going to the next slide is that we come to task allocation. Now, this is a very, very important point where we talk about how the tasks should be allocated. If you look at the graphic in this on the slide, it tells you that the major perception is that 78% of the jobs which can be repetitive or which can be just monotonous can be delegated to machines or to automation. There are unpredictable physical work jobs, cutting of trees, forestry, raising outdoor animals, and again, most importantly, jobs where human logic and reasoning is required are the ones which should be in the domain of the human operator with help from the automation system. The three stages of task allocation, therefore, after keeping in mind what we have just seen in the videos and what we've discussed earlier, is one is the leftover principle. Normally, tasks are allocated by these three principles: the leftover principle, the comparison principle, and the complementary principle. We'll take these one by one. The leftover principle considers always, when designing a system, that the operator is most unreliable, that he will make a mistake, so let's put automation in this place. This is the basic premise of the leftover principle. The leftover principle also then thinks, okay, this is what cannot be done by the machine, let's get it done by the operator. So let's push it into his domain of work. Everything cannot be automated, so let's have humans also. Let's try to make a compromise here and there, but not exactly keeping in mind his abilities. The pitfalls here in this kind of system actually is that the operator needs to be much more vigilant. He is overloaded, and his cognitive requirements are not kept in mind while deciding on these issues. This is where the whole system of task allocation, according to leftover principle, fails. So this is not the right system to allocate tasks. You will also all agree. Now, the second one is a comparison for the allocations. Whether we want to compare, you can see it in the slide, whether we want to compare how the task is allocated between an automated system and a human operator. We have to realize that the human operator and the machine have different capabilities, and the tasks are allocated according to that. We allocated the tasks to the agent, which is better suited to perform the task. That is the other one. In the same way, overall operator tasks may be corresponding to human capacity. So the human being has the capacity to do this work. Let's load him full. Whatever is left, then we'll put it onto an automated system. If you see the comparison of the characteristics, the most important characteristic, what men can do better than machines, is the last one, that is the ability to reason, what we have just seen in the examples before, and the ability to exercise judgment. Large amounts of information and long periods can be done by a human operator, which the machine is not able to do. The machine is able to respond quickly to signals and to work faster. It is able to perform repetitive functions without getting tired, which a human being might. The ability to handle highly complex operations is also with the machine. The highly complex operation is very, very difficult for the operator. It is very difficult in terms of physical labor as well as mental strength of the operator. Then we go finally to the complementary principle. The complementary principle is the best evolution of the first two, the leftover principle and the comparison principle. Because both the leftover principle and the comparison principle have limitations while deciding about the human aspect. The complementary task allocation method actually takes into account how the machine or the automated system can complement the human operator. The human operator and the automation system have to work in conjunction. They have to work together to perform the task to the best of both of their abilities, rather than just for one. So the complementary principle is the one which is normally decided by the designers who design the perfect system. The complementary principle also takes into issue that performance is a dynamic process. It can be difficult to foresee, so therefore the system design has to keep into mind when it is building the complementary process of how machine and human beings have to work together. And the limit of technology. Sometimes the complementary principle is not able to really give the final product because there is a limit of technology versus adaptability of humans. So there is a limitation on both the systems, so the automation system is not able to perform. Now, repeatedly we have seen that the human factor is of great importance in the production system for flexibility, innovation, quickness, and imagination. The human part in the production system is still considered to be incomplete in a full automation system because it lowers the level of automation. Therefore, automation comes into play where the speed and the accuracy will be complemented by the flexibility, innovation, and imaginative process of a human mind. The human consciousness that originates from the brain, as the slide says, is manifested especially in thought, perception, and emotion. Those are also very important aspects, especially in the example we just saw and for the application into such technologies. The slide, as you can see, tells us that once the automated system comes into operation, the operator's role changes drastically. The operator moves from primarily involving into the operation to primarily involving supervision. I'm not saying that the complete control is handed over to the machine. As we have said, that the human supervision plays the most crucial role in an automated system to perform to its best ability. Supervision is of great importance in an automated system. An automated system, like an in-flight system of a plane or of a self-driven car, or the sensors even in your normal car, which tells you, which are called proximity sensors, that your car is near to another car or another object, still depends upon the corrective action that the operator will take. So the supervision needs to be constant. The alarm can come, but if it is not supervised, it can still result in an error or an accident. Deviation handling. If the process has got deviations, it is the human operator only who can handle deviations. The automated system or the interface does not possess the 100% capability of handling deviations. We will have ranges, we will have tolerances in every system. Again, the issue of reasoning and logic comes into play, which the human operator has to handle. There is a very good saying by Bainbridge that the designer who tries to eliminate the operator still leaves the operator to do the tasks which the designer cannot think how to automate. This is a very relevant statement, that the biggest mistake the designers of an automated system make is that they try to eliminate the operator, but in the end leave tasks which the system cannot do to the abilities of the operator. Now, this is a mistake which we should not repeat and which we should not build into our design of the system. So coming from here, if we really follow this golden rule, we come to the human system interface design issues. The design issues while designing a human and an automation system interface are monitoring of load. That is the workload planning. We are not, because when we do not take the operator into account or do not take the abilities of the system into account, we are not able to do workload planning. Either the system will be overloaded or the operator gets overloaded, and we are not able to really balance out these two things. Vigilance, control and corrective action. The issue which really needs to be kept into mind is that the human operator as well as the system both need to be vigilant. The feedback needs to be given on time, and corrective action needs to be taken on time for corrective action. Workload distribution allocation, which is again monitoring of load in a way, but then allocating the tasks according to that workload distribution. The complexity of the automation. The complexity has to be such that if the automation system requires, the operator is able to handle it, and he is able to manage in the absence of the automation system. Automation surprises. Sometimes we see in operations where the human aspect, because it has not been taken into account while designing the interface, creates surprises where the operator is at a lack of ability or training to handle automation surprises. The complexity is a part in this surprise. Continuing with the system interface issues, if you look at the slide, the representation of the system activity is and results into certain problems for the operator. One is physical and mental isolation. A very good example of this is once the automatic transmission cars, automobiles came into operation and came on roads, the event of a driver falling asleep on the steering has increased. The automobile companies have started building in systems of alarm, which if they sense a monotony in the driver operation, if they see that the car has been going for a very long time in a particular direction but is now veering off course, gives a software indication that the driver has gone off to sleep. So they're trying to build in and gives an alarm. However, taking everything like this into context, we still have physical and mental isolation of the human being while designing an automation system. An automation system which is doing repetitive tasks and the operator has to just load the piece on a machine results into a mental and physical isolation of the human being. This results in a lot of other issues which we will discuss later. Workload distribution too high and too low, as we discussed. Because the interface has not been designed properly, the workload between the automation system and the human being differs. The complexity also makes it difficult for the operator to handle the system. His trainings, his education, his level of understanding needs to be much more to adapt to the system with a high complex level in the automation design. Out of the loop is a part of mental isolation. The human aspect is such that if the operator or the human being is kept out of the loop, then suddenly when the system requires him to be in the loop, it becomes difficult for him to take corrective action. Such issues normally arise in either the production lines or in space, where the automation system in space travel depends so heavily onto automation systems that once, if the person in the design has been kept out of loop and a problem arises, he can no longer handle it. Technical design, and in terms of human factors, there is the one which says compensatory activity may hide deviations to the operator. So there is a compensatory activity in the sense that if, let's take an example of a CNC machine. If the machine has started running the wrong codes on a machining cycle, the machine will try to self-correct itself, or there is a temperature compensation, then according to tool wear, the machine will start trying to compensate itself for tool wear, which the operator will not know. And the codes might change, the cycle might change. Reduced time span because of the high speed and complexity of the operation. The time span to take corrective action by human beings is very less, microseconds. This aspect can be seen in any operation which is running at a very high speed, which an example for which I gave you earlier also. And deviations need to be handled by human beings with the system interface helping him into taking timely action. In the design of human and system interface, the degree of automated system should be done in a way that is transparent for the operator. So one of the most important factors that comes into play is that the human operator or the human being who's associated with the automated system needs to be aware step by step of what the system is doing, the ability of how the system is performing. The operator or the human being cannot be blind, or he cannot be cut off from how the system is performing. Now, these interfaces are or can be handled, these problems can be handled in way of feedback from the system in various ways. The system itself keeps the operator or the human element updated on various changes, progress, and work as it is carrying out. These representations or the kind of feedback that the human operator gets can be in form of text, it can be in form of graphics, it can be form of sound. So there are alarms which will tell you if there is a deviation or there is a movement which is contrary to the program. There is a graphic which tells you whether the activity that is being done according to the way the system has been programmed or the way system is to run. And text gives you a continuous display of how the program is moving, whether it is in line with the monitoring system, whether it is going out, or whether it is within control. Now, these information which is represented to the operator or to the human being associated with the automated system can be explicit presentation of main activities. What we can see is, like, if in a CNC operation, the graphic display gives you the complete tool movement and what exactly is happening on the product. The machining which is going on is graphically represented and it can be seen by the operator whether it is moving in line or not. He can toggle between representations of graphic and data. The graphic feedback which comes back tells you how much of the cycle has been completed, what is the status of the cycle, where exactly in what situation or status is the present operation in. Again, the majority of these applications in an automated system or the kind of interface and the representation information that we get can be seen in a very, very clear way in the way aeroplanes and its own handling systems depict all this information to the pilots. The pilots have graphic, explicit, and verbal, all representations at the same time available to the pilots so that they can take corrective action, they can handle the situation, and then can take a decision based on all this information which is being given to them. Going by the earlier system which we had in 63, the systems that we had in the aircrafts was so one-sided that you had approximately 400 instrument clusters in which the pilot had to keep a watch to take the right decision. We are not just talking of 5 major instrument panels: the altitude, the bank angles, the speed, or the RPM, and the direction. But we are talking of multiple, or in terms of hundreds of clusters which the pilot had to take in account while taking decisions. This all has been changed because of the information, the way information presentation to the pilot, in this case the operator of the system, now gets this feedback. We have graphical representations, we have audible alarms, we have HUDs, which is called head-up display, in which the screen is projected onto the windshield or the glass in front of the pilot so that he does not have to remove his eyes from the front and to look at the instrument cluster where the alarm is on. All this technology and the representation has helped making it safer, making it better, and increasing the effectiveness of the system and decreasing the workload of the operator, in this case, the pilot. So, verbal, semantic, meaningful feedback. We go on to the next slide where it just gives you an example of how the information presentation can be given or was given. In terms of CNC machines, it is conventional interface, main process components that will be shown, main process flow. This can be a flow diagram which can keep on coming on the screen. Control formats. This was the information that was normally relayed back to the operator. Automatic devices now have been incorporated. Computerized logic diagrams help the operator in the operations. Verbal feedback, again in terms of alarms and the machine speaking back, also give an example of this. So designing of an automation system has various aspects. And because we have time and again said that the most important aspect in this whole thing is the human being. And we have talked about collaborative, we've talked about complementary design interfaces. We've talked about the aspect of the importance of the human being in the center of the design. Once we start designing an automation system, the first and foremost concept that is taken is called human-centered design, or HCD. Human-centered design of an automation system is the case where automation isn't the only thing which is considered in the design process. The human participation is also taken into account. So this has 3 central attributes. It focuses on the roles of humans in complex systems, what they will do, how they will engage. Design objectives are elaborated in terms of human roles, what role the human being will play in this whole thing. Specific design issues that follow these objectives are to be kept into account. The primary objective in designing is, 1, to enhance the human abilities. Any automation system, once it is taken into account or when is being designed, it has some objectives to fulfill. 1 is to enhance human abilities. The second is to overcome human limitations. Human limitations, for an example, in a lot of industry, a lot of applications where heavy loads are to be shifted repeatedly throughout the day, it tests human capabilities. So robots or automated systems help in overcoming these human abilities to a large extent. To foster use of acceptance, the design objective has to be such that the operator or the human being involved in the whole system takes acceptance to this and is not resistive to this acceptance. He should not feel threatened by the system, or he should not feel that his work is being taken away from him. So the design objectives are very critical that we have to keep in mind before doing this. Now, coming back to human-centered automation. The human-centered automation, as it says, is designed to work cooperatively with the human operator in pursuit of stated objectives. So the three objectives that we talked about of overcoming the inability or the effectiveness of the human being, to speeding up the process, being more effective, and being helpful in the sense that there are no issues with the human being accepting the system. They have to be within this view, and the automation system has to be designed to work cooperatively with the human being. The assumption here is that the human being has to always be the main starting point for any design process. It cannot be started from the machine. It has to take into account the human being, his abilities, his shortcomings, and where we need to help him overcoming that and the process. Sorry. HCA, to take it further, the human-centered automation design system, has to first keep the basic premise in mind. That is that the human operator must be in command. We cannot take away the command from the human operator, because taking away the command from the human operator again puts at risk a lot of issues which we have discussed earlier: taking corrective action, not getting hang of the complexity of the system, not being able to respond faster to errors. All this comes into play. So once we have taken that the human operator is to be sent in the center of this command, why is it to be done? One, because so that he's able to command effectively. The human operator must be involved, then only he'll be able to command effectively. To command effectively and to be involved, the human operator must be informed. So he has to be a part of the feedback system. Immediate feedback or immediate response has to come to the operator to feel involved and to command the operation. The human operator must be able to monitor the automated systems. Monitoring, again, informed is a part of monitoring. So if there is regular information, he will be able to monitor the system much more effectively. The automated system needs to be predictable. Unpredictable systems will result in accidents and errors, which the human operator will never be able to handle. It has to be a predictable system. When we design a process flow and we design an automated system response and feedback system, it has to be predictable. Unpredictable behavior, either from a machine or from a human being, can never result into an efficient operation or a safe operation. The automated system must be able to monitor the human operator also. Now, this goes into a second aspect where the human operator also should be monitored by the automated system. The example that I gave you is in the latest automobiles. This system is there. The automobile software is able to take feedback from your driving methodology, the way you have been turning or the way the car is moving, to decide and take a call on whether you are going off to sleep, whether your reflexes have become slower, and it automatically and immediately warns the operator, in this case the driver, that he needs to stop and take a break because his reflexes have become slower and the vehicle is showing signs where the system is getting a feedback that the operation is not within control. Now, this is the basic and essential part where we see it in our day-to-day lives. More complex systems, like in space exploration or even in flight, these systems are even more, where retina sensing, eye sensing, and all those effects are also taken into account, where they are able to monitor the pilot or the operator here in this case and see whether he needs to be monitored properly for making it a safer environment. Each element of the system must have knowledge of the other intent. That means the operator should know what is the intent of the machine, and the machine should know what is the intent of the operator. If this is very, very clear between the two, then the automation system works effectively and in optimum capacity. This is an example, the slide of the human-centered automation system, which is in aviation. Aviation is one of the fields which has used this from a long time, where this has been developed to a large extent, and where even more advancements are taking place every day. By aviation, we also go into space shuttles, into rocket technologies, into higher airplanes, which are being, like we said, generation 3 aeroplanes have already come into operation. We are moving towards generation 4. So just going through the slide will give you an idea of how the humans, according to HCA, have to be in command and how it will help in the automation of the system. Automation can assist by providing a range of management options. That means in logic, if the automation assists by providing a range of management options, the pilot is able to take a logical decision. Otherwise, the logic is left only to his own perception and understanding. If the pilot is involved, the automation system can assist by providing better and more timely information. So aids judgment, whether he can turn, whether he can land in this circumstances, what is the wind velocity, what is the temperature, what exactly are the air pockets. So all this can assist in timely information, can help in taking a better judgment. If the pilot is more informed, the automation can assist by providing explanation of its actions. So graphic and voice interface. As you saw in the video, the automated system gives a warning on whether he's flying too low and there are obstacles in the path, or whether he needs to turn, whether the fuel will last or not. Every information can be provided to him with intentions and actions. The human operator will be able to do a better job of anticipating problems if monitoring trends and providing decision support is given. So in certain automation systems, analytical data, graphical representation of that data is provided to the operator to take a better call. We sometimes feel that automation is only restricted to space and automobiles because those are the maximum examples that I've been giving. But it's not like that. Even somebody has an automated system on his laptop through which he's, let us say, monitoring the stock shares market. Now, the software which is running to analyze the software and the software which is doing the analysis of the stocks and shares market is an automation system. It is able to give you this data in graphical form, trends and analysis, with which you can take a better informed decision of what you want to do further. So let's not only assume and let's not keep ourselves closed because I'm saying that automation is a part of the industry only. It can be a part of any industry, for that matter, finance industry, logistics industry, production industry, aviation, everything. Human operators, for ease of operation, the designer can assist by providing simpler, more intuitive automation. So this will have and help the human operator in ease of operation. A properly designed and used automation can be most useful. So that means selection and training. So you, for a particular activity, need to decide with the human being in mind of what complexity you have to have in the system, what is the automation that you would like to have in system, so that it is easier for the operator to be selected and to be trained on it. Sometimes technology decides and determines what kind of training you will have. There are simulators for car driving now. You don't have to go to a driving school. There are simulators for aircrafts. But still, if it is a much more advanced, complex technology, like let's take, for example, the recent example, which is always in the news nowadays, the Rafale aircraft that we are buying. The pilots have already been sent for training. So this is a part, because it is a highly complex, advanced aircraft, you need to send them for training. However, just for landing and taking off general single propeller aircrafts, there are now simulators which can train the pilot. So technology and automation, how it needs to be taken into account for designing with the humans, has to also take into account how and what level of training the operator will have to get the system into operation. So human-centered automation is the prime requirement today. It is also a requirement that if you do not take into account these issues, the operator feels alienated, as we said, both mentally and physically, as well as he feels threatened that he has not been consulted or been taken into account while designing this automation system. So it is the replacement for him, which becomes a very critical factor while deciding. We will now touch upon the effects of automation on humans, because we've been just discussing human-centered automation and we discussed the points. The thing which comes immediately to our mind is, with rapid full automation, we have to very fast and quickly think about human labor. We have to redefine our entire value system and redesign theories. Occupation, jobs have to be provided to people. It is one of the most important aspects where people feel valued. We cannot have a society in which we have joblessness, in which we have people unemployed. We cannot have a level of automation where it is not taken into account what people can do and people are rendered jobless. So we need to have a system and we need to have automation where the effects of automation with humans are also taken into account. Some of the important issues that need to be taken into account, other than automation replacing human beings, is the cognitive skills which will be required with new technology, with new automation, the frequency and the reuse. A very good example of this is the phone. When we had a normal phone which had to be dialed by hand, it is a practical example that people who have worked in those ages will recall, as well as people who used to use those phones will recall, that they could remember at least 100 to 150 telephone numbers by heart, because they had to. There was no other way. Now what has happened is, with smartphones which has a contacts list running into thousands, you are not able to remember more than 10 phone numbers. This is a fact. If you will yourself try to recall how many phone numbers do you know by heart, it might be 5 or 10. Earlier, this never used to be the case. Before the advent of the calculator, which was one of the first earlier examples of automation, sorry, you could do mathematical calculations in your head. People of the earlier times could do multiplications and divisions of a large extent just by thinking about it and doing the calculation in their mind. Now we have reached a generation where if you ask them 12 into 6, they will have to pick up a calculator to do that calculation. So this is the effect of automation, which is on human beings. We have reduced feedback, reduced memory, which are examples which I've just given you. In the organization, the effect automation has is on motivation. If the human-centered automation design is not taken into account, motivation is a very big factor which comes into play and affects the morale of the worker. The worker might have worked for a bonus or an incentive or satisfaction where the number of pieces that he produced were a part of what he was earning. Also, to show his skills, his effectiveness, his capabilities, there was a number with which he could be associated, that this worker has won a prize because he could provide X or produce X number of pieces in his shift. If the automation system is designed without him, the effect that it has on his morale, with people saying, oh, it's the automation system producing, it is not you, his capabilities are undermined and his motivation level goes down. The other aspect is, he will always feel threatened that my incentive is going down because now I'm no longer associated with productivity. Job satisfaction, it results into the same thing. The motivational factor, when it goes down, the morale goes down, job satisfaction starts going down, and the operator will never perform to his optimum level. Safety, because the worker will become complacent. He will think that the automated system will take care of itself. He will not be that vigilant. Again, we come back to reduced feedback, reduced memory, which are effects of automation. This also results in complacency. The complacency results in accidents. You will find that although automation helps in giving alarms, but if the operator is not vigilant enough and because of repeated working day in, day out on an automated system, his reflexes go slow, and that results in lack of safety. Have a look at the slide, which gives you a direct idea of how the workforce will change in the coming years. The kind of automation that we are going through and what we are reaching at, it is going to have a direct effect of human being involvement in its jobs. If you have a look at this, just about 75 million to 375 million, that means 7.5 crore to 37 crore people will have to switch occupations just because of automation in the coming few years. This is because of how the automation is affecting our lives and our jobs. They will have to switch this occupation if they want to remain employed. And they will have to also upgrade their skill set. I think the biggest reason for the Skill India and also skill development is a factor to keep into account. And that's why the government is going with it. And we should all now think in those directions that Skill India and skill development are an integral part if we want to move and if we want to keep with times and also take up the competition which is coming from abroad and also take the country further. This is where the skill development will help. And this is what we need with the kind of new automation and new technologies coming in. Demanding new skills. If you look at this graphic, applying expertise will increase. You will be an expert in an automated field or in a field. So expertise will gain more jobs if you're an expert in a field. Interacting with stakeholders, team play, we will have more jobs. It will increase. Managing people will be already slightly less, but you will need managers and surveillance. Unpredictable physical labor. Definitely this will remain within the operators because unpredictable physical labor is not the domain of a machine or an automated system. As we said, cutting trees, rearing animals, dairy farming, all this will not be automated and this will remain within the human angle. However, areas and industries like processing data will become fully automated. Jobs will go down and they will go away. Collecting data. Till now or till a few years back, you had people coming door to door who were asking for how many people live in this house. Whoa, are you an engineer? Are you a doctor? Please give your occupation. What is the age? All this will stop. These people who are gaining employment, or we used to say the Indian data analysis system was more manual oriented, is never going to be like that. The new automation systems in place or the systems of data collection that have been made now without you knowing it. It's a very simple example. Your Aadhaar, your PAN card, everything is being linked to your bank numbers. The government has this data now. It has the analysis even of your economic status, number of people, their education level, and everything. So these kind of, I'm just giving an example, these kind of data analysis, data reports, even to the extent, how many people, let's say somebody starting a school, and he says that I need data in the city of what is the literacy level. It is available on the computer. The data is being done by softwares, which is already gathering data from everywhere. Facebook is one of the biggest suppliers of data to all agencies which want to take this kind of information from the net. We have had issues where Data Analytica, Britannica Analytica has passed on information to a lot of competitors and a lot of people where the government had to step in and say that this is illegal. So just taking that illegal thing away for the time being, we are now talking of that these kind of jobs will no longer involve humans. This is available on the net and this is available through automated systems. You will also have predictable physical labor. Predictable physical labor is, let's assume, packing. It will be done by automated robots and automation system. As I told you, in confectionery company, filling of jars with bubble gums, it is automated. Capping of jars, packing into cartons. All this will have lesser jobs. Even by 2030, most probably this will have negligible jobs. Automation is going to take over and people need to be ready for it, and the skill development needs to be developed to that extent that we are able to switch occupations. This is just an idea to give to people of how the world is moving. We also have changing educational requirements. The changing educational requirement is secondary or less. Advanced will go down, but in emerging, it will go up. In associated fields, the emerging will go up, but in the advanced, it will remain the same. College and advanced is going to remain the same because you will want to have more people who are graduates and college educated, because it's going to be more of data analysis and understanding rather than going into an absolute skill set. But as we said, expertise and skill sets will go up. That is where the whole thing will change. If you're talking of intermediary, that is going to go down. Nobody wants intermediary or intermediate qualifications or educational requirements anymore in the future. Now, coming to, after having talked about human beings, human-centered automation, use of human beings and automation system in a collaborative way, in a complementary way, designing of automation systems keeping humans in mind. There are, however, issues which need and which have to be kept in mind, as also in one of the earlier slides that we have taken, that errors where the humans are responsible in an automation system have to be kept in view while designing of a system. So if you look at this slide, which shows you, just going through that, you will find that faults and errors in human actions are basically seen where there is heavy cognitive load and outer disturbance. Heavy cognitive load in the sense that too much is left for the operator to decide and too much is left to his logic and understanding, as well as an unpredictable situation. Human error is bound to go up in situations like this because there will be time which will be consumed, and every person from logic, having his own logic and own perception, will change the judgment according to his own perception. Human error actually is defined as this action that fails to meet explicit or explicit standards regarding of the performer or the different one. So if the situation changes and if the performance is changing, human error is defined in the action that fails to meet this change. Regardless of human knowledge of the field and the action, training we have to do, humans shouldn't be treated as error-free. So even in spite of the training that they get, humans cannot be taken as error-free. It is not only machines. Humans are more prone to errors. In this case, the automation is a primary issue for error-free environment, especially where cognitive and a lot of heavy outer disturbances are taken into account. The automation system takes in and is more error-free than the human being. Because the automation is robust and flexible, capable of handling different tasks. Where automation exists, the best principle to implement it is inform permanently the operator about the behavior of the automation system. So what we are saying here is that if there is a good interfacing between the human operator and the automation system, the errors can be reduced. So we go on to of how the automated system needs to be controlled. What is the human interaction to control it? So when we are designing a automation system, the shared control is one of the options that is taken. So in the shared control, they are working together, the human being as well as the machine. And the parameters are manually controlled. Others are controlled by the computer system. So like let's say in a CNC machining, there is a program which is running. However, the speeds can be controlled by the operator depending upon his own logic. He will change the speed of the machine. So he has certain controls and parameters which are within his control. And there is a program which is already running according to the coordinates and how the machining has to take place. This is a kind of a shared control. The shared control can also be seen in areas like self-parking cars, where in cruise controls, where you have put it on cruise control and the automated system takes over. However, the operator also has a shared control in the sense that if he puts his foot on the brake, the cruise control automatically shifts back into manual control. So there is a shared control of the whole system. This is one of the options of the design of an automation system. The other one, which is better, is a flexible control. The human beings remain the supervisor of the system during the process, but at the same time may change the status of the system into direct manual control. This is very, very relevant in flights, in aeroplanes, where the plane can be on autopilot, but depending upon the situation, the pilot can always take control. This is also done in flight training aircraft, where the co-pilot has the controls, but at any point of time, the main pilot, if he feels that the trainee pilot is not behaving according to the requirements or has the system out of control, can immediately take control of the system. It is a very good example of what can be done with human beings and with automation systems to have a shared control. So the need of the hour is to have flexibility in the system. The system has to be robust, but yet flexible to adjust to the needs. And this can only be done when the human angle and the automation angle work together to create a flexible system where the automation system is driving it for speed and accuracy. However, the human intervention is always there depending upon the feedback and continuous transparent information which is relayed back to him to take control and to get the best output from the machine. If you'll have a look at this slide of flexibility, it definitely says that flexibility is of great concern. We know that because this flexibility does not exist in automation systems to that extent which we want. Flexibility is a multi-dimensional concept that couldn't be measured and clearly defined. However, from technological point of view, flexibility characterizes process as easier, faster, with the capability of changing the level of performance. That's exactly what I was saying, that the system, although being fast, error-free, and working according to a set program, however, but still retains the flexibility with the human intervention of making a decision, taking a logic into account, and taking corrective action when desired. So flexibility can be desired as the ability to respond effectively to changing circumstances. So this is where it comes, and this is where the collaboration has to happen between humans and automation. We will just show you two videos here again, which give you the present use of how automation and human angle has come into allocation of tasks, where we are using automation, where actually if only human labor was used, it would have resulted in much lesser productivity, would have resulted in a lesser efficient process, how the automation has helped in this, and also take you through of how automation is moving ahead for the future to keep in mind these collaborative issues and really take technology to a newer level. So just have a look at these, and then we come back to the slides again.
Some economists say making robots.
Well, they're making love to these robots. Making babies. Yes, right.
To see how they're changing manufacturing and whether they're sealing the fate of low-skill workers. Every other year, Tokyo plays host to the world's largest robotics trade show, IREX. It's no coincidence the show is in Asia. Here, robots are being bought and sold in numbers unrivaled anywhere else in the world. These are the types of robots Professor Eric Brynjolfsson is keeping an eye on as MIT's chief scholar on the digital economy.
We used to have to really painstakingly teach the machines step by step, program them what to do. And now machine learning is enabling the machines to figure out on their own how to solve problems. You put together the algorithms, the data, and the computer chips, and you get sometimes a million-fold improvement in the performance of these systems.
Million-fold improvement.
Yeah.
And what does that allow you to do?
So one really important thing to do on the factory floor is just be able to recognize objects. And that's something that only humans could do well until recently.
At IREX, we witnessed a robot handling a task that I, as a human, don't do so well, futzing with one of those pesky tape dispensers. It's among the latest offerings from Yaskawa, one of the world's largest manufacturers of industrial robots. Its main sellers are large industrial robots that do dangerous things like welding car parts. We visit one of Yaskawa's robot manufacturing facilities in the southern port city of Kitakyushu. Here, the public can try controlling and racing against AI-enhanced robot arms.
You're done.
We got to see where the robots are made.
The robots themselves, they're sealed off by these plastic barriers. The workers aren't allowed to be in there while they're in operation because they're making these very fast movements.
The head of the robotics division at Yaskawa, Masahiro Ogawa, seems most excited to talk about robots that don't need to be walled off from humans, that work alongside employees. In the industry, they're called cobots. The International Federation of Robots predicts in coming years, cobots will lead the robotics industry. That's partially with driving startups like China-based Elephant Robotics to get in the game.
Heated people, so you just stop.
Yeah.
So work with people.
Yeah, works with people.
Yeah.
We asked their founder, Ju Yi Song, how his cobot is different from traditional robot arms.
It moves not that quick, and it is very, very light.
Okay.
So it can work with people. So this is the most important thing.
In addition to being safer, the collaboration proves to be more productive. A study conducted by MIT researchers found that human-machine groups were more efficient than teams wholly comprised of one or the other. They also reduced human idle time by 85%. While traveling through Japan, we visited Huistenbosch, a Holland-themed amusement park. There we checked out its latest attraction, a robot restaurant.
How many okonomiyaki pancakes can the robot make in an hour?
今のロボットで焼ける枚数っていうのは1時間でだいたい5、6枚ぐらいだと思います。まだまだそんなに早くない。でも、それだけ丁寧に作ってますから。
My colleague Matt McDonald, after getting a robot mixed cocktail, tried the robot chef's signature dish.
特に日本ではどんどん少子高齢化で、特に若い人たちの人口がこれからどんどん減っていく、これがもう目に見えて迫っている状況ですから、じゃあいかに効率的にこのレストランのオペレーションができるのか、いかに少ない人手で。
It's gimmicky by design. Back at Yasukawa, Ogawa tells us most of the customers who come to him looking for new automation solutions come from China.
China market huge, and the growth ratio very high.
How high? Last year, Chinese demand for robots grew more than 20%. One reason for that is China's working population is aging. By 2060, the average Chinese citizen is projected to be 50 years old. To see the impact of industrial robots on manufacturing in China, we traveled to an area that's considered the electronics capital of the world, the Pearl River Delta region.
So just to hold it a little bit here, the idea to show you here was that it gives you a very direct insight into cobots. The idea that we were talking about in human-centered automation design, where we are talking of collaborative and complementary automation. Cobots is the direct descendant of this philosophy. And as you must have seen, the experts in the field also were commenting upon that the day of robotics is finishing off and the day of cobots is the future. The idea to show this video was just to take you through to what the future holds and what exactly are we moving towards. So this video gives you a direct insight into that there has to be a collaborative effort and the robots have to collaborate with humans. That is why they're called collaborative robots or cobots. If the worker and the robot or the automated system are able to work together, that is the best for the industry in terms of error-free and speedy productivity or resource or achievement of targets, whatever we call it. It can be in any industry. So let's not limit ourselves to the production or the production lines in a manufacturing facility. The collaboration of the automated system and the human being is the most important aspect of any automated system to be implemented in any facility. So let's move to the next, where we see that the human automation cooperation in critical fields where it can take place. The latest field in which this has been inferred, and this is going on at a very fast pace, is medical robotics. Medical operations, surgeries are now being done by robots but controlled by human beings, in the sense that the doctor is able to analyze the whole system. He's able to see the patient. He's able to detect the symptoms, the area of operation, and through the robot, and the simulator that he controls, he's able to do an surgery or an operation with very high precision and an error-free mode. Eye surgeries, heart surgeries, brain surgeries are now being on a large scale being done through medical robots, however, but being controlled by a doctor. You cannot expect to really let the doctor let the robo work alone. The robot will never be able to work because it is the judgment and the logical decision of the doctor, the analysis which the doctor has done of what has to be done where. Again, these are decisions which work in collaboration the best, and the outcome for a patient to have an error-free, high-precision surgery done by a robo being controlled by a doctor is the ultimate that you can think of in human automation, collaboration, cooperation. Space is another field, as we've discussed earlier. The astronauts, their instruments, the equipment are controlled even from the space station down on Earth to help them out in activities which they have to do in space. The data analysis, the data being collected, the analysis of that whole data, giving a feedback to the astronauts and to the space station is again done through systems which are thousands, in fact, hundreds of thousands of miles apart from each other. Defense is another field where automation and human cooperation is happening at a large pace. Drones used to attack and neutralize terrorists or targets which are supposed to be unsafe for human beings or for human civilization are controlled by human beings at a remote location, and the attacks are carried out. Defense radars, data again referring to alarms, to detection. Everything in these fields is being done to a large extent with the cooperation of human and automation. So these are very, very critical fields where we are moving together and which give an example of how human automation cooperation can work to the benefit of the society. Okay, coming to the next slide, we have the relationship between machine and humans. Sharing is common for the species, and it's a way of communicating and exchanging information. As I told you, or I had given an example in the lecture in the morning, human beings are the only species on Earth which can communicate with logic, with visualization, and exchange information. To a larger extent, now human beings itself are developing artificial intelligence and automation systems to the extent where this information can be exchanged for the benefit of everybody in view. Sharing a complex process and exchanging ideas and thoughts was till now the singular domain of human beings, but now through automation systems is again being done to a large extent over hundreds of miles being apart and away from each other. Because sharing is a complex and difficult phenomena, we talk about the sharing between a human and an automated system because of the tasks that they can achieve working together. The automation system provides the speeds, the human system provides the logic and the cognitive facilities, and together they can achieve much more than each system standing alone. The conclusion to which we come is that the combination of human and automation control is most desirable. The collaboration and the human aspect, if taken into account while designing a human interface or a human automation interface, is the one which will take the society and technology further. The purpose of the automation system is to perform and evaluate all necessary tasks, but it can do it more effectively, much better, and in a much more logical way if the human angle is also into account while designing the automation system, and the fine balance in this collaboration is maintained to take technology and effectiveness of the automation system further. Thank you. Thank you.